So in this Python tutorial, our objective will be to learn that how to create an interactive linear regression y equal to mx plus c from the data. And here the interactive means that we will vary our error in y data, and then we'll notice the corresponding variation in the slope and intercept of the fitted line. So these things we will be using a demo to visualize in a real time. So here you can see that here is my plot. So I have data with a noise in the blue, and I have this red line is a fitted linear regression, and here I have this y error data. So if you change the your y error, so you can see there is your slope intercept. So as you like increase the error bars in your y data, so you can see corresponding your slope and intercept is changing. Okay, so this is what I mean by saying interactive linear regression. So sometimes you have like set of data points, like you want to get your optimum fits, so you can do this interaction by varying your error in y data, and you can notice that where is particular slope and intercept of the fitted line is obtained. So same stuff we have to do it using Python coding, and I will be using library such as NumPy, Matplotlib, Scipy, Curvefit, and IPy widgets. So let's do it. So for doing that, first of all, in Python, we need some inbuilt library. So let me import libraries. So libraries required. So I will need NumPy. So import NumPy as np. So this will take care of your number and arrays. And then I will import matplotlib. So import matplotlib dot pyplot as plt. So this will take care of your plotting, right? And this will take care of your array and numbers, right? And then I will import the curve fit for fitting your linear regression. So from Scipy dot optimize import curve fit, right? So this will be used to fit your linear regression, right? Then I can use widgets to vary your y error in a real time. Okay, so from IPy widgets import interact and plot slider. Okay, so this will use for interaction with y error. Okay, y error. So now these things we have imported. Now go to the next step. So our next step will be to define our variables, right? So variables. So first I will define my x data. So I can define my x equal to np dot say linear space, and I want to go from say 0 to 20 or 0 to 10 or say 20 data points, right? So this is how my x look like, 0 to 10 and 20 numbers. After that I will define, so this is just call it here x data, and then I will define here my y data. Okay, so y data in terms of line. Okay, so such that y equal to mx plus c. So you can see here y, okay, y equal to, and then you can give say you want to give say slope 2 point, define your y equal to say your x, your say slope. So slope you can give any say 2.5 you can give into x, and intercept you can give as say 5.0. Okay, so this is my becomes a simple line. Okay, so you can plot it if you want. So plot it, you can type here plt dot scatter, and you can call it x comma y. So this is a simple plot, right? Now what I will do, uh, I will fit this linear regression. Okay, so for that I will so now define function to fit a linear regression, right? So you can define say define uh, line. Okay, and then give the bracket. You have like your input is x, and you want to obtain your uh, slope m and c intercept, right? So you want to obtain these three things, and then you want to give return function as mx plus c, right? This is my function to fit a line, right? Now I will define function to update y error in y data. Okay, so for that I can define a function, define say update fitted line. Okay, and then you can give your error. Okay, so just call it say y error, right? Y error, and then you want to return your, then you want to give your y error. You can define here y error, you can define equal to say you can define say np dot random, right? Random and random in random dot normal distribution, and then you can give say your mean, and then you can give your deviation as a y error, and y error, and then you can okay, so you need to make it say Y error. Okay, let's call it noise, not noise. Okay, and then y error, and then you can the same size you can give as same as your x or y data, right? So x dot shape, right? And then you can uh, define your y uh, noise equal to your y from previous data and here then you add your y error. Okay, this is your becomes your uh, data with error in the y. Now this much I have done. Now I will fit. So fit data points, fit data points with y equal to mx plus c. Okay, mx plus c. So for that I will record your POPT and optimize parameter. Okay, and then peak variance. So this is my optimized parameter which will give my slope and intercept, and this will give my error. Okay, so taking a square root of diagonal 2 plus 2 matrix, this will give my error. So make it equal to and pass my curve fit, and you can give your say your your linear model, this line, right? A line, then you can pass your x, your y noise, right? Your y noise data, and that's okay. So this will return my parameters. So if you check it, see what returning, nothing. So we need to print it. So print POPT, nothing is giving. Okay, so we need to update it, leave it. So now we can plot a figure. So plt dot figure, right? And then you can type my plt dot scatter uh, x y noise, right? And you can also give label equal to say data, right? And after that you can plot your linear model. So plt dot plot your x sim. Okay, then you call your this function line and x, and then evaluate at its optimized parameter. So this is star is global declaration of POPT. So it will take both values together, right? And then you can type here label equal to fitted line, right? Now I will then type here plt dot show. Okay, and yeah, that's all. And then you have need also like for the legends. So plt dot legend, right? And you can also like pass your parameters in your uh, label. Okay, so you can give your label as a fitted line, just type here printing format AF, and you can such that y equal to your optimized parameter, and it's 0 will give the slope, right? And up to uh, up to 2 decimal points, right? And in a similar fashion, you can also add your uh, intercept POPT1, and then uh, POPT1 such that 2 decimal points, right? 2 decimal points, and close it, right? This will print my on the label. So after that, I will use. Okay, so run it. So, yeah, so the code has run successfully. Now I will add. So add here, interactive slider. Okay, so for that type here interact, right? Type here interact and update plot. Okay, so you have this updated filter line. Okay, so I will call this function updated filter line, right? And then I can pass my error. Okay, so error as a slider, so I can give a float slider, right? And I can give some parameters, say your minimum value equal to 0, then max 5, and then you can step 0.5, so like how it will increment, and you can give an initial value equal to say 1.5, right? Now run this whole code, and what is mistake here? Y error. Okay, so there should be Y error. Okay, not just yeah, now it's fine. So here you can see that I have a simple plot, right? And now if you vary here your Y error, so you can see here we have this plot. Now change this Y error. Okay, so only this value is changing. It means there's a mistake. So let me check this code. I think here there should be noise. Okay, not error. So there is some error here, mistake. So correct it. Now run this code. Now look. Now interact with this Y error values. So yeah, here you can see when the error is 0, the line and the scatter plot on your they are like matching. So like when you slowly increase your Y error, you can see the scatter in your data point is increasing, and corresponding your slope, and corresponding your slope, there should be x. Okay, so corresponding your slope and your intercept is varying for y equal to. Okay, so this is what I mean by interactive. So you can see this is how your data is spreading, and your slope and intercept for the best fit among this data point is changing. So this is how it appears. You can play around it. You can give a number of values if you want. You can go 50, and you can see this is how your slope of the line is and the shape is changing. Okay, right? So this way you can make an interactive linear regression plot by varying your y-axis. Okay, I mean the y error in your y data. So I hope you got the ideas that how to make an interactive plot using NumPy, Scipy curvefit, Matplotlib and IPy widgets. So this is all about, and let me review the code once again for grasping the coding part. So first of all, I have imported libraries as NumPy, Matplotlib, curvefit, Scipy curvefit, and interactive and float slider from IPy widgets. Then I have X data. Then I have Y data equal to mx plus c line, and then I plotted this data points to visualize. And then I've defined a function y equal to mx plus c to feed this data. After that, I have defined another function called updated fitted line, so which will update your fitted line depending upon your y error as an input. Then I have defined noise in your y data. Then I have added that noise in your y data. After that, I have fitted this parameter with p of 50 as the optimized parameter and p covariance as a error in their uh, respective fitted parameters on M and C. Then I have plotted the original plot, and after that I have plotted the fitted line, and I've then opened the formatting with legend in this format y equal to mx plus c. Then I have used interactive control as interact, and then I want to operate my fitted line with this plot, and then I have given my y error as a slider, okay, as a float from 0 to 0 minimum, 50 is maximum, and in a step of 0.5, and my initial value is 1, okay. So this is how my result will look like. So you can play with it, and you can check that for which y error, like how much value is for slope and intercept. So thank you, and stay tuned for the next videos.